So myself Naveenraj and welcome all for the digital circuits. Today's topic is a shift register. So we all know that there are two circuits, combinational sequential circuits, which is used in digital circuits. And the combinational circuit, we don't need of any feedback signal. Here in the sequential circuit, we need we will give a feedback from that is the signal will be taken from the output and given to the input once again. So under this sequential circuit we are going to see about the shift registers. So what do you mean by register is nothing but a device which is used for storage purpose, right? So normally in memory element we use it to store the data, and whenever we need we can retrieve the data, right? So similarly here if we want to store the data in digital circuits, we need to store the bits, right? So that is for that purpose we are using the register. But the difference between the register and flip-flop is nothing but flip-flop is a single bit storage cell, so it can store only one bit, but the register is nothing but a group of flip-flops. So if you want to store n number of bits, you can use n number of flip-flops. If you want to use 4 bits, you want to save or store the 4 bits, you can use 4 flip-flops. Okay, then what do you mean by shift register? So as now you are clear about register, right? Now this shift register. So for shift register, so it will be like what you can say, the data which is stored already in the register can be shifted either right or left shift. Okay, so either right shift or left shift you can move, so that you can go for some other operations or any other operations if you want to perform. So the data must be moved from one place to another place. So for example, if you take any industry related example like bottle filling, you can take the example of Sprite or Coca-Cola or Miranda. So these industries using this type of shift registers for filling their bottle. So it is used as for example, if you take serial in, serial output register, it will be given to the bottle to fill the drinks, and also it is for packing also they are using the same method of shift registers also. So the bottle will be moved one by one, the machine will be filling the bottle one by one serially. Okay, and the bottle is moving in serial out manner, but the filling method is happening in parallel method. So parallelly you are filling the 4 bottles, or 4 plus bottles you can fill parallelly. So this shift register can be divided into, you can feed the input and take the output in two different manners, serial and parallel manner. So the input can be given either in serial or parallel, and similarly output is also taken serial or parallel. So by considering this, there are 4 types of shift registers: serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out. So on any circuit which performs all these operations we call as a universal shift register. Then we have a shift register counter also. So this count is nothing but a ring counter we are using as a shift register counter. Now what the ring counter will do is it circulate the data among themselves. So we are taking the output of the last flip-flop and connecting as an input to the first flip-flop. So next one is serial in, serial out. So it provides a delay element, because even if you want to send a data 1111, so you have to wait for a 4 clock pulse, because you are using 4 flip-flops, so you have to wait for 4 clock pulse to get the to store the data at the output. Okay. So in order to avoid this delay, we are going for serial in, parallel out. So serial in, serial out will be using only for the long distance communications. Serial in, parallel out means they are used in communication lines to convert your serial data into parallel data. So we are sending the data one by one, but you can take the parallel outputs on the end of the each flip-flop. Okay, so this is a serial to parallel conversions, and you have problems in shift register. That means the register will have a content of 0 1 1 0. The XOR gate will be connected between last two flip flops, and it is given as input to the first flip flop. So whenever you you give a clock pulse, it performs their operation and moves one bit right to the cells. Okay, so the initial content for the 4 bit is given as a 0 1 1 0 here. So the question is, what will be the content of the register after 3 clock pulse? Okay, so for during first clock pulse, it shifts the bit and performs the XOR operation also. In the XOR operation, you all know that the both inputs are same, the output will be 0. If the outputs are different, inputs are different, the output will be 1. Similarly, you have one more problem in under the shift register. The shift register, here the question is, the initial content will be given as 1010. If the clock is applied, then they are asking how many number of clock pulses is needed to retain the original input back. So same input 1010 they are asking once again, but you have to say how many number of clock pulses needed to retain the original signal back. So that's all about the today's class. Thanks, and we can see the solution of these problems in the next class. Okay.